8 is a section that we've already done and applied. They're just going to take it to another level. In applied, we would be able to solve two equations. For example, if we had y equals 3x minus 4 and y equals 2/3 x minus 2. Okay, so I asked you to solve them. We learned three methods in which we were to solve these. And two of them were algebraically and one of them was graphically. So today we're going to focus on graphing. The difference between what we've done before, which is just lines, is today we're going to actually work with parabolas as well. So quadratic equations. So again, the very first thing you can do is you can graph this on your calculator. So take out your calculator and we'll just figure out how to graph that. Punch in the equations. So the first equation was y equals 3x minus 4, correct? Yeah. Okay. So there's that line. So we would go down to minus 4, and then our slope tells us to do what? Up 3, right 1, correct? And the second equation was y is equal to
2 over 3x minus 2.
2 over 3 x minus 2.
Yeah.
Okay, so what's our y-intercept in this question?
Minus 2.
Minus 2, so we go to minus 2, and where does it tell us to go? What does my map tell us?
Up to right 3.
Up to right 3. Okay, and so my intersection point is down here. Okay, now it's not an intersection point that is a whole number, so you need to find this on your calculator. So how do I find my intersection point on the calculator? Second function, calculate, right? Intersection. You done it, right?
0.857 and negative 1.429.
Okay, so let's just write that out. So your coordinates then are 0.857 and
Negative 1.429.
429. Okay, great. So to begin with today, all we're going to do is we're just going to work with the graphing, okay, which is all calculator work. And then we will solve questions after this. Today is just graphing. So let's do it. We'll do a couple more examples, and then we'll go back to the algebra part. So for example, this question, if I were to solve it algebraically, I can do one of two things. We can use the sum and difference, which means you get them lined up and you add and subtract them. All right, so we've gone through that. And then the second method was to do the substitution, which is what I would do here. We know that y is equal to 3x minus 4. And y is equal to 2/3 x minus 2. So I can let them equal each other. Because we're trying to find out what's the coordinate where x and y match or meet. Okay, where they intersect. So then I would solve it, move everything to one side, and then solve for x, and then I would substitute it into one of the equations and solve for y. But that's tomorrow. So today we have an equation. First equation is y plus, help me out here, 3x squared minus 2x minus 4 is equal to 0.
Yeah.
Okay. And the second equation is
Plus x.
y plus x plus 2 is equal to 0. Okay. So we need to be able to graph these, correct? And in order to graph them, what do we got to do?
Equal to y.
Okay, so how am I going to make those equal y?
Subtract like from the y on, or add it depending on what it is. Like, so you can subtract 3x squared plus 2x plus 4.
Yeah. Okay, sure. All right, so y equals. The easiest thing actually in this question would be to move the y over and then times everything by -1. That's probably the easiest, but we'll just do it. We'll subtract that. So minus 3x squared plus 2x add 4. Okay? Then I've got y is equal to -x minus 2. So what are the two shapes I'm looking at right now? Are they both lines?
One's a line,
One's a line, one's a parabola. How many solutions is it possible if I have a line and a parabola?
0, 1, or 2.
0, 1, or 2? So exactly, we can have a parabola drawn as such, right? Now I can have a line that crosses, gives us 2.
Excuse me for the interruption. Also moved into the office, please.
One that touches can give me 1, and then I can have one down here in which I would have no solution. And all three are possibilities. Okay? So, first thing we'll do then is let's graph these. Clear this off. Okay, so the first equation is y is equal to, what is it, negative 3x squared?
Yeah.
Negative 3x squared.
Minus 2x
Plus 2x?
minus
2x minus
4, or plus 4.
plus 4?
It's minus 2 and then plus 4.
Okay. So minus 2x
Plus 4.
x plus 4. So there's the first graph of my parabola. Okay? Now, what we did in applied is we would have to do that by hand. We wouldn't use the calculator for that. Okay, so you would either complete the square or whatever, but we don't have to do that in this class. This class is all calculator work, so that's what we're going to do. So the second equation is y is equal to
Negative x plus minus 2.
negative x
Minus 2.
minus 2. Thanks. And there we go. Okay, so now I have two coordinates, one right there, one right there. Two solutions for it. Okay, so what are the solutions? So we got to find the intersection point. So do that right now, please.
-1 and -1.
-1, -1. Okay.
2 and -4.
All right. Now look back at that.
My calculator got to -4 as well.
So what did we do wrong here? Is there one of our equations wrong? I have minus y equals minus x minus 2, right?
Or plus 2.
Is it plus 2 instead of the minus 2?
No,
No,
it'd
no.
be minus 2.
-2.
So what do we have wrong then? Does that look like the right equation for that? Minus x minus 2 is right. Okay, so I can graph that. But the other one, are we sure
Your
this is right?
parabola, like on my graph, it's on the maximum values on the other side of the.
So it should be minus 3x squared.
Yeah.
Plus 2x plus 4. There's the error. So I'm going to clear the graph. Clear the screen. I'll graph this one again. 3 plus. Is that it there?
Yeah.
Okay. And then I've got to graph this guy. Now, if I take my cursor, it's on that spot right there, and now you've got it right. Okay? So the only thing that we can do, or the only mistakes that are going to get made right now, because you're just punching it into your calculator, is actually the algebra part that we've got to put in there properly. Okay? So far, okay? Alright, so we're going to look at intersection of lines. We're gonna look at intersection of a line and a parabola, and we're also gonna look at intersection of two parabolas. Okay, so how many possibilities can we have if we have two parabolas? How many possibilities for solutions if you have two parabolas?
0, 1, or 2.
Same thing, right? Can either touch the same vertex, which is 1, not touch at all, which is 0, or they're going to cross in two spots, right? So let's look at page 335. So I'm just going to rewrite this. So I've got y is equal to 3x squared minus 12x add 16. So I've already got it into y equals form, right? Y equals negative 4x squared plus 16x and minus 12. Okay. So before we punch this into our calculator, I'm going to show you what we're going to end up doing tomorrow. Okay? So I've got two quadratics right here. And somehow, some way, I need to solve these two quadratics. So before we punch them into our calculator, because you're going to check, even though we do it algebraically, we're going to check with our calculator all the way along. All right. So today, I'm just going to introduce this so that tomorrow we can do a couple examples right off the start. So here's what happens. I'm going to get rid of the y's. How do I get rid of the y's here? Subtract. So I'm going to subtract. In other words, what I'm going to do is I'm going to change all of the second signs and add it. So basically, I'm going to multiply everything down here by minus 1 and add it to the top. So I get that's a subtract, and that's an add. Okay? So y subtract y, 0. 3x squared plus 4x squared, 7x squared. Minus 12x subtract 16x, minus 28x, 16 and 12, 28. Okay, so we've spent roughly 2 months on this now. I've got a quadratic equal to 0. How do I solve it? Factor if we can, right? So what's the very first thing that we look for? Is there one? 7.
Yeah.
So because we're solving, we can actually divide everything by 7, right? We don't need to keep it there as part of the solution. So I divide by 7, it gets me x squared minus 4x plus 4. So far, so good? Is this factorable? Are there factors of 4 that add to give you negative 4? What are they?
Negative 2, negative 2.
Negative 2, negative 2. So I go 0 equals x minus 2, x minus 2. Right? 0 is equal, or sorry, x is equal to, what's my x equal to? X is equal to 2. So now we need to find out, okay, first of all, let's talk about that. I have one solution, so what does that mean about those two graphs? Before I graph them, what does that mean about those two graphs? If I have one solution.
You only need that 1 point.
They meet at one point. What's that point called? The vertex. The vertex, they must share the same vertex if they meet at one point. It's the only way it'll work. Okay? Otherwise, they have to cross. All right, so let's find out what the actual vertex is. I'm going to put 2 back into the top equation here. Okay, 2 squared, 4, 4 times 3, 12, 12 subtract 24,
Negative 12.
negative 12, add 16,
4.
4. Good work. 24. Okay, so now what I want you to do is I want you to graph it. So graph those two equations. Okay, so now, what's my first equation? What's the first equation?
3x squared minus 12x plus 16
3x squared
minus 12x
minus 12x.
plus 16.
Thank you. Alright, so. Okay. And the second equation,
Plus 4x squared
so 4x squared
minus 16x plus 12. No, it's the other way.
Well,
It's,
so what did I miss? Missed
it's
the negative.
minus 4 and then plus 16.
Minus 4, and do draw. And that should be a minus there,
And
Yeah.
plus 16.
and a plus 16.
Yeah.
Okay. Remember I switched them to do the algebra, right?
Yeah, but if you...
Oh, I still got a problem. What am I got wrong here? So let's go back to this just a second. So it should be minus 4x squared plus 16x minus 12. Minus 12, that's what we got wrong. And voila. Okay, so I have it, intersection point. How many of us didn't get that on your calculator? Okay, so let's have a look. Better be what we put in for equation. Minus 4x squared, it should be a plus 16x here.
Yeah, I get an error every time I have a negative in front of it.
Okay, you have an error,
Yeah.
you're using the wrong negative, aren't you?
Uh,
You gotta know whether, if it's, so for example, because it's in front of this 4 here and it's not a subtract, you have to use the negative. But because it's subtract out here, you have to use the subtract sign, so that's where the errors always occur.
yeah, I got it now.
Okay, good. Any questions about that so far? No? Okay, so again, you've done this already, something very similar to it in applied. Finally, today, you have problems that go with this. So this is where we're going to struggle a little bit with, so we're just gonna have to do as many as we can so that we don't struggle with it. But again, the graphing should be easy. All you do is punch it into your calculator, provided you get the right signs on all of the equations, right? Page 337. Two numbers have a sum of 17. The square of the first number plus 5 equals the second number. What are the two numbers? All right. So, two numbers have a sum of 17. Okay, so there's two ways in which we can approach this question. The first way is to use x and y. Now there is a way in which we could do it if we just use x, but because we're going to use the calculator, we need the y in there. So how do I write the first equation? How do I write two numbers that have a sum of 17? What does that look like?
X plus y equals 17.
Fair enough. Okay? X plus y equals 17. Now in grade 10, we would have written this as x and 17 minus x. So then we wouldn't need the y. But because you're doing this, and we have squared values, we have to use the y. The square of the first number plus 5 equals the second number. So how do I write that? The square of the first number plus 5.
This squared, or no, squared, so x squared plus 5 equals y.
X squared plus 5 is equal to y. There's the hard part. Okay? Because now all you need to do is arrange it so that it's in y equals form and graph it. So let's do that. So the top one, y is equal to minus x add 17. And the bottom one is already in y equals form, x squared and 5. Okay, so let's graph those two. First one minus x plus 17.
Yeah.
And the second one is x squared plus 5. Okay, so what are you going to have to do right now? Because the way your calculator is set up, you're not going to see those graphs. So what do we got to do?
Change the window.
Okay, so you can either do one of two things. You can change the window, or what first? Yeah, let's zoom fit first and see if we get both showing. And if we don't, then we'll go to window and we'll adjust the window so that we can see it. If you look at my graph right now, just judging, you see where the intersection points are about here and here. That's a y value of 14 and a y value of 21. So you want to have your maximum y value at probably 25. Your minimum can be around 0. And then your x, if you look at the x down here, mine's minus 6 to plus 6 would get it to you too. So if you wanted to change your window, your x minimum would be minus 6, your x maximum would be plus 6, scale, x scale is 1, and then go 0 to 25 as your y minimum, y maximum. Do we get it? Does everybody see their graph now? Do you have two intersection points?
Mhm.
Everybody can see two intersection points? Zach? Okay. What are the two intersection points?
3 and 14 for the one on the
3 and 14?
right side.
On the left side is -4, 21.
Negative 421. Good. That's all there is to it. Okay. So again, I'm going to show you this just because we're going to do it tomorrow. You don't have to do it today. I have this equation as written, just the way it looks there. All right. I want to
Mr. Kolick, you're wanting the gym fees, Mr. Kolick?
solve this algebraically. So this is something new to you because you have a line and you have a quadratic. So how do I solve this again? I need to get rid of the y's. So what am I going to do to get rid of the y's? Subtract them. So I'm going to change the signs here. Like that. So I've got 0 is equal to minus x squared minus x plus 12. You know, that looks awkward, doesn't it?
Yeah.
So what I should have done when it comes to this is I had y equals x squared plus 5.
Yeah.
What I would do differently is I've already got both as y equals, correct? So instead of using the adding and subtracting method, the elimination method, I'm going to use substitution instead. So I'm going to write it as x squared plus 5 is equal to minus x plus 17. Okay? So what do I have to do? What do I do for any
Isolate the
quadratic?
variable.
Okay, but which variable?
Equals 0.
Get it equal to 0, right? Any quadratic always equal to 0. So x squared plus x minus 12 is equal to 0. Good so far? Okay. Two sets of brackets. Factors of x squared, x and x. Factors of negative 12 that add to give me 1.
Positive 4 and -3.
Plus 4 minus 3. Therefore, x is equal to
-4 positive 3.
-4 and positive 3. Now remember, those are the x solutions. Now, what we have been trained to do up to this point is just find x's because those are x-intercepts of graphs. But realistically, we need the y value now because we're talking about intersection points between two graphs. So I need to substitute this in to one of the two equations and solve for the other. So the first one I'll go y is equal to minus 4 add 17. So actually I'm going to do this more formally so then you get a better idea. F of -4. So what I'm doing is I want to know what my y value is when x is -4. So f of -4. Plus 4, add that, 21. So what's my coordinate? -4 and 21. Okay, now I want f of 3 equals -3, add 17, which is equal to 14. So my coordinate is 3 and 14. Is that what we got when we graphed it?
Yeah.
Okay, good. So tomorrow we do this first, and then we graph it. So today, all you're working on is your ability to graph, find the window, the correct window in order to see the graph, and use your intersection to get the points. Got it? Okay. So, like I said, I don't think this section is going to take us very long because we've already done all of this already once this year. All right? Okay. We got the remainder of today to work on that.